Hello and welcome to my lesson. My name is Mr. Johnson and today's lesson is a GCSE lesson on chemistry, GCSE on ionic bonding and ion formation. So I'm just going to share my screen with you. You should be able to see what I've got there now. Okay. You might need a pen and a piece of paper while you're watching this, just to take whatever notes you need to take. And here we go. So prior knowledge, what you need to know from Key Stage 3. You should remember from chemistry the definition of an element, compound and mixture. You should be able to recall and identify some properties of metals and non-metals and their general position in the periodic table. You should also recall that energy is needed to make chemical reactions happen and that sometimes energy is released during a reaction. By the end of this lesson, you should be able to describe how ions are formed. The next thing you'll be able to do is describe how ionic bonds are formed between a metal and a non-metal atom with examples. The final thing is to describe how some more complex ionic bonds form between atoms from group 1 and 6 or group 2 and 7. So let's take a look. First off, you need to remember the periodic table. This is given to you in a chemistry exam, so you don't have to remember everything. Now, there are some things about this periodic table that are going to make it very, very useful when it comes to your exams and talking about ion formation. First thing to know is that elements in a column or group have the same number of electrons in their outer shell as the group number. So if I'm looking at elements in group 1, which is the first column going down the periodic table, hydrogen, lithium, sodium, potassium, rubidium, they all have one electron in their last shell. Elements in group 7 electrons in their final shell. Elements in a row or period have the same number of electron shells as the period number. That means however many rows you're going down is how many shells you've got. Hydrogen and helium are period 1, the first row. They have 1 electron shell and it holds a maximum of 2 electrons. Period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, they have 2 shells. Period 3, sodium, magnesium, aluminium, 3 shells, and so on as you go down the group. Again, quick recap, metals are on the left of the table, non-metals are on the right of the table. If you're ever unsure, look for something that you know, for example, oxygen. You know it's a non-metal, find its position on the table, and you know that side is non-metals. Then you find something that you know that's a metal, for example, iron. You can see it's on the right-hand side of the table compared to oxygen. Metals are on the right. Let's get into a bit of a recap. Subatomic particles. Atoms consist of 3 types of subatomic particles. There's the proton, the neutron, and the electron, and they are present in the atomic structure. The protons and neutrons exist in the dense nucleus at the center of an atom, whereas the electrons orbit the nucleus in layers called shells, sometimes also called orbitals. Each shell has a maximum number of electrons that it can hold. Electrons will fill the shells nearest the nucleus first. So here we have 3 shells around the central nucleus as represented by the red circle. The inner shell is filled first. It holds 2 electrons. The second shell filled second. The third shell on the outside filled third. The first shell holds a maximum of 2 electrons, and that's easy to remember if you have your periodic table, because in that first row there are only 2 elements, hydrogen and helium. The second shell holds a maximum of 8 electrons. Again, easy to remember because if you count the number of elements in the second row of the periodic table, there are 8. The third shell holds a maximum of 8 electrons. Atoms of noble gases, the last group in the periodic table, group 0, have completely full outer shells. That means that their shell, their last shell, is completely full. It contains a maximum of 8. It makes them very unreactive or very stable. And this is key to understanding what happens with ions and ionic bonding. Now, as well as that, we also have to understand that subatomic particles have electrical charge. Protons have a charge of +1. Neutrons are electrically neutral. And electrons have a charge of -1. Atoms have equal numbers of protons and electrons. That means their overall charge is 0. If I have 10 protons and I have 10 neutrons, I have 10 positive charges and 10 negative charges. So overall, the charge is 0. Fluorine, as my example, it contains 9 protons, which means it has 9 electrons. So I have 9 positive charges and 9 negative charges, giving me an overall charge of 0. It has 10 neutrons, and neutrons are electrically 0 anyway, so the total charge of this atom is 0. Atoms are more stable, however, if they have a full outer electron shell, I should say, I apologise, just like the noble gases in group 0. If it's not full, they can get a full outer electron shell. But to do this, they have to transfer electrons between themselves and another atom. And this forms charged particles, which we call ions. So here are 2 atoms. On the left, I apologise for the blurry picture, is sodium atom. It is in group 1, so its last or outer shell contains 1 electron. On the right is chlorine. It's a non-metal atom from group 7. It contains 7 electrons in its last or outer shell. They are unstable. To become stable, they need to gain a full shell. So what is the easiest way for sodium and for chlorine to get a full shell? Here's our sodium. It has 11 protons. The proton number tells you how many protons are present, and so we can use that to work out how many electrons the atom has. If there's 11 protons, there's 11 electrons. But the outer electron can be removed. This means that sodium is no longer an atom. It now has a full electron shell underneath, and it is electrically and reactively stable. However, it has 1 less electron than it started with. It has lost an electron. So now it's no longer an atom, but a charged particle called an ion. So here's our sodium atom drawn out. It loses the outer electron, and that then means that it now has a full shell underneath, which makes it reactively stable. But because it has 1 more proton and 1 less electron, it's now become a positively charged ion. And we name it sodium plus or Na plus, with Na being the agreed upon symbol for sodium. So an ion can be shown like this to show the electron shells, where we use square brackets around the outside of the diagram, and then the charge outside to show the whole ion is positively charged in this case. Or it can just simply be shown like this, Na plus, to say that that sodium atom has a 1+ charge. How do these atoms form ions then? Well, let's take a good look. For this, I'm literally going to focus on their last shell. I'm going to ignore all shells underneath. Sodium is in period 3, so it has 3 shells normally. The first shell is full with 2 electrons, the second shell is full with 8, and the last shell contains only 1. Now, energetically, it's easier for sodium to lose that electron than it is to gain 7 more to fill that third shell. So sodium will lose its electron. And when it does that, it forms a sodium ion, which we denote like this. That third shell is empty, but it has a full outer shell in the second shell underneath, which makes it electrically stable. Chlorine needs to gain an electron. It's energetically easier for chlorine to get one more electron to fill that third shell, which already contains 7, than it is to lose those 7. It can gain it from anywhere. It can be an incoming electron, or, and this is key, if there is an atom nearby that is going to lose an electron, chlorine can gain it from that atom. And when it gains that electron, it becomes negatively charged. And we denote it like this. You can see that it has gained the electron from sodium. We can also write the shell electronic configuration. So for sodium, it's gone from 281 on the left to 28 plus on the right because it has lost the electron. For chlorine, we can say from 287 on the left to 288 minus on the right because it's gained an electron and now it's negatively charged. So this is how ions are formed, the loss or the gain of electrons. Right, so ionic bonding. What is a bond? A bond is a force of attraction between atoms that hold them together. When bonds form between atoms, energy is released. That release of energy makes the atoms more stable. The most stable atoms in the periodic table are the noble gases, those in group 0, because they already have a full outer shell of electrons. So they do not need to lose energy, or they do not need to gain or lose electrons. They are happy as they are. Every other atom in the periodic table aspires to be like that. It wants a full shell, and to do that, it will transfer or gain electrons if it's metal and non-metal atoms. Ionic bonds can form between metal and non-metal atoms then through the loss or gain of electrons, as we demonstrated before. Here's our slide away, the easiest way to get sodium to get a full shell, chlorine to get a full shell. So sodium 281, chlorine 287. The metal atoms always lose electrons. Anything from group 1 and group 2 will lose their outer shell electrons. They are metal atoms. In doing so, they form positive ions called cations. It's very important that you remember this terminology because as well as in this part of your GCSE, it will also appear in your electrolysis lectures for your electrolysis and electroplating part of your chemistry GCSE. Cations have more protons than electrons, which is why they are positively charged. Non-metal atoms gain electrons. They form negative ions called anions. Anions have more electrons than protons, and this is why they form negatively charged ions. That extra electron that they have gained can come from other atoms that are giving them up, such as our sodium. And this forms this arrangement. Now I've got a positively charged sodium atom and a negatively charged chlorine atom. That positive and negative charge are opposites. And that opposite charge causes an electrostatic force of attraction to occur. And this causes the formation of what we call an ionic bond. An ionic bond is a bond due to that electrostatic force of attraction between two different oppositely charged particles, in the same way that two opposite poles of a magnet will attract. So, a bit more detail, dots and crosses. The sodium atom loses one electron and becomes a positively charged sodium ion. The chlorine atom, using crosses as the electrons, it needs an electron, so it gains the outer shell electron from sodium. This fills its outer shell, and now it becomes a negative ion. Because they have full outer shells, both ions now have stable configurations, and they will not react any further. So, what is an ionic bond? The ionic bond is literally the electrostatic force of attraction between oppositely charged ions. It gives the atoms involved in the bond a full shell of electrons each, where some atoms have gained electrons from the atoms that have lost them. And that's our second outcome. Describe how ionic bonds are formed between a metal and non-metal atom with examples. Final outcome, describe how some more complex ionic bonds form between atoms from group 1 and 6 or 2 and 7. So most ionic bonds are formed between metal and non-metal, and the table I'm going to show you in a minute shows how the number of electrons lost or gained relates to the group number of the element atom. It's another way of remembering it in an exam. If you've got a group 1 element, a group 1 metal, it has always got one electron in its outer shell, which means it will always lose one because it only has one in its outer shell. That means it will gain a positive charge. The example being lithium, Li+. Group 2 has 2 electrons in its outer shell, so it will lose those 2. It has an ion charge of +2, and an example is magnesium 2+. Group 6 and 7 are non-metals. We've already said that non-metals gain electrons to gain full shells. If you're in group 6, they have 2 spots. They have 6 electrons in their outer shell. They need 8. So they will take 2. And if they take 2 electrons, that will give them an overall charge of -2. So, for example, oxygen in group 6 will form an O2- ion. Group 7 has 7 electrons in its outer shell. It needs 1 to make a complete 8 for its shell. So it will take 1 to form an ion charge of -1, and the example being chlorine, making a chloride ion, which is Cl-. So what happens if we have a group 2 ion and a group 7 ion? We've said that group 2 has to lose 2, but group 7 only needs to take 1. And this is where people get confused. Group 2 has 2 to lose, and it needs to lose them. It can't just give up 1 and then say, all right, I'm fine, I'll stop there. It doesn't like it. It wants to lose those 2. Magnesium is our example of group 2. It has 2 electrons in its outer shell, needs to lose them. Chlorine has 7 electrons, and it only needs 1 to fill its outer shell. It will happily take 1 of those electrons from magnesium, but now it's full. That leaves our magnesium with a charge of +1, but it still has 1 electron left to get rid of on its outer shell. Chlorine's now quite happy with a full outer shell, but it has a charge of -1. Because of this, magnesium still needs to lose the 1 electron, and it will give it to another chlorine atom. That chlorine atom also needs to gain an electron, and it will take it quite happily from the magnesium. And this then means that that now also has a charge of -1, but the magnesium has lost 2 electrons to become +2 charged. So I have +2 magnesium, and I have 2 -1 chloride. That then gives me an overall charge of 0. These 2 attract, and we form an ionic bond between them. What if then, instead of group 2 and group 7, I am using a group 1 metal and a group 6 non-metal? Sodium has 1 electron in its outer shell. It only wants to lose 1 electron. It can't lose any more than that because then it'll dip into its full outer shell underneath. Oxygen, however, needs 2 because it's only got 6 and it needs 2 to complete the shell. So, sodium quite happily gives up that electron to become a sodium 1+ ion, and oxygen becomes a 1- ion. But oxygen still needs 1 electron from somewhere. It's not happy, it won't stop there. Sodium's got nothing left to give. So another sodium now comes along with an outer shell electron that it needs to lose, and it will give it up. Both those sodium ions now are quite happy with a charge of +1 and a full outer shell underneath. And now the oxygen ion is quite happy because it has filled its outer shell. It just took 2 things to give up the electrons for it to get full. Again, the 2 negative charge from the oxygen is attracted to the 2 1+ charges from the sodium, and this forms a stable ionic bond between them. So a couple of examples, I've got KBr, lithium fluoride, magnesium oxide, and calcium sulfate. Potassium's in group 1, 1 electron in its outer shell. Bromine is in group 7, So it has 7 electrons in its outer shell. And potassium plus has no electrons in its last shell, it's given it up. But the bromine minus has taken that electron and now has a full outer shell of 8 electrons. So this is potassium bromide. Over here, we've got lithium with 1 electron in its outer shell. And we've got fluorine, again in group 7, with 7 electrons in their outer shell. Lithium loses its outer shell electron. And fluorine takes it. So now we get lithium fluoride. I do apologize. It shouldn't say K+, it should say Li+. Magnesium has 2 in its outer shell because it's in group 2. Oxygen has 6. So magnesium wants to lose those 2 to get to the full outer shell underneath, and it will form an Mg2+ ion. Whereas oxygen needs to gain 2. It'll take happily the 2 from magnesium, and it will form an O2- ion because it's now gained those 2. Calcium's also group 2. Sulfur's in group 6. Calcium will lose its 2 electrons to become 2 positive, and sulfur will become a 2 negative ion in the same fashion by taking those 2 from calcium. And that's how we describe some more complex ionic bonds and how they form between atoms from group 1 and 6 or 2 and 7. Thank you very much for watching. I hope that has been useful. Have a nice evening, and I'll see you again next time.